Thank you. As you just mentioned, my name is Max. I work at ThinkMill as an open source developer. ThinkMill is an Australian agency. We're based in Sydney. I'm not based in Sydney. I'm based in Vienna, Austria, which is halfway around the world. I maintain Keystone.js, which is our Node.js content management system that you might have heard about, and Elemental UI, which is our React.js UI library. I'm also the creator of React Boilerplate. And we recently released the third version of this boilerplate, where we did an entire overhaul, starting from, I think, December last year. We worked all the way until a month ago, trying to really make it the best foundation to start your next React project from. And I'm here today to share a few of the things that we've learned along the way. This talk has four big sections. The first one is, what is scalability? Second one, state management. The third one, architecture, and we'll close with a bit of performance. Now, scalability is this thing that's traditionally mostly existed on back-end systems, right? When you created a new project or a new product or a startup, you had to make sure your database was set up in a way that it would manage being split across multiple servers. So when you suddenly had a bajillion users, which you wanted, right? You wanted to be able to get that database and split it across multiple servers, because you would run out of physical space sometime. And if you didn't do that, you'd have a problem, because then you'd run out of space. And suddenly your database is full, and you can't actually do anything, and the users can't create new accounts, and it's a pain in the ass. Sorry. This has sort of translated into the front-end world. We have these very rich web applications, these very complex, business logical, and really big applications. And we now need to make sure that those scale in three different ways, right? We need to adapt to having a ton of users. We need to adapt to having lots of developers working on it. And we need to adapt to the application itself having lots of different parts, right? So that really is scalability. Scalability is handling more users, more developers, or more parts of your application. Every big application will have state. You will have some sort of state. That might be something like a modal is open, or it might be something like, a user is logged in. It might be some sort of data, but you will have state, and you will have to manage it. What we used to do is called two-way data binding. If you've ever used Angular or Backbone, you know what I'm talking about, right? A component deep down in the component tree changes. And it goes back to another component and says, hey, component, I've changed. And then that component might do something. But it also goes to another component and does that component, hey, component, I've changed. And then those might go further and say, hey, those components, that component has changed. And it goes all the way around. And in the end, you end up with this tangled mess of updates that you can't really follow. And if you've ever had to debug a big Angular application, you know what I mean. This is a really common debugging problem, where you end up with a really complex flow that you're trying to follow, but you have no idea what's happening. When Facebook open sourced React, they also open sourced Flux, which is a unidirectional data flow library. That means that when something changes in our component tree, somewhere very far down, what happens is, instead of going to another component, we go to an external entity called a store. That store, as the name suggests, stores our state. That store then does something based on the changes in the component, and it goes back to the top-level component of our application, tells it to re-render, and that then re-renders all of its children, and those re-render their children. We have a completely re-rendered application. The nice thing about this unidirectional data flow library is that it makes it really easy to reason about what's happening in your application. You've got this cycle of updates that just happens over and over and over again, and you can track what's happening where, why is this being updated? Oh, because something somewhere changed. Right, it went over to the store, that was the state changes, that's why this happened, blah, blah, blah. It's really nice to debug, it works really well. The problem with Flux was that it was based on events. It emitted events which you would then catch in the store and update something and emit a new event that the state changes. And while that worked, it was really hard to test. You had this problem where you had to mock certain events exactly in the way that Flux wanted them. It was really, really hard to test. So at React Europe last year, Dan Abramov went ahead and open sourced Redux, which is a unidirectional data flow library that works in a very functional style. It has pure functions everywhere. It's very easily testable. You can add middlewares. You can compose everything. It's really nice and works really well. this ties into our architecture. When you have a Redux application, you have certain components in your React application that are connected to the store. These get some sort of state, they grab some of it, and then they pass it down maybe, or some other components are also connected. I've found it very useful, and many people apparently do that too, to split them between containers and components. Containers are connected components, components that have access to the state. They are concerned with how things work. Components, on the other hand, are solely concerned with how things look. So you get this separation of data and logic and styling and how things look. And the nice thing is, when I'm changing some sort of data structure, I'm adding a new API, something has changed, I know I only need to go into my container, I need to change the data structure there, but then if I pass down the same things to my components, they'll just work. I don't even need to check. And if I'm changing the styling, I know for a fact that I'm not messing up some sort of business logic because there is none there. It makes it really easy to reason about what you're doing. It gives you a lot of clarity in the code base because you end up just editing exactly what you want. Now, React applications have traditionally been structured by type, right? You have your files, and imagine, as an example, a navbar component, a container, that has some actions associated with it. It has some state, you know, if it's open or closed, and then it has an action saying, hey, we can toggle it and open and close it. This is what many people do and used to do and still do. What you often see in examples is you have an actions folder, a containers folder, a constants folder, a reducers folder, and you have a navbar action somewhere, you have a navbar constant somewhere, and this works really well for really small applications. But you end up with this, if you have a big application, you end up with these 6 folders that just contain thousands of files, and you're like frantically digging through them, trying to find exactly the one you want. And if we want to add something to our navbar, we're going to have to dig through 5 different folders trying to find exactly the files we want. We're never sure, are they used somewhere else, are they not? What do they even do? It doesn't work. Instead, group your files by feature. Oh wait, sorry. Group your files by feature instead. So, what if we just take all of those navbar files and put them in the same folder? There's 2 big benefits to this, right? The first one is easy renaming and moving. Renaming this navbar to something else is as easy as renaming one folder and then doing a search and replace in your editor and changing everything to a different name. But really, how often do you end up renaming things? Like, that's not a very big benefit, is it? The much better benefit is that as a developer, you can work from a single folder. You only go into one folder. I know I need to add something to my navigation bar. I only go into a single folder. I know I've got everything related to that in there. I only need to change the files there. You never end up thinking, hey, wait, is this actually the thing I want? You know exactly, okay, that's where I go, that's what I have to do. It's so nice to work with. We had a huge discussion on the React boilerplate repository when we decided to revamp everything about this application structure thing. And there were tons of people chimed in telling us, hey, try this, we're doing this and it works really well, you know, what about this? Have you tried this? And I tried all the things, and I heard about this and I thought, well, that sounds like a horrible idea. Like, why would I want to do that? It's worked fine the way we've been doing it. And then I tried it on a tiny project, and I went, whoa. I never want to build React applications differently. It's immensely nice to work with. I encourage you to try it, group your files by feature, and then tell me afterwards that it's not nice, and I won't believe you. Because I'm building all my applications that way, and I've told everybody I know to do it, and it's just, I've never heard a negative thing about it. Also, what it sort of gives us is this nice reusability, because we have all of our files associated with our navbar in that one folder. We could just push it up to npm and then npm install it, and then use it in different applications, right? If we're a company and we want to reuse our navbar, we can simply npm install it, and all our changes will be semantically versioned, and it's always the same navbar wherever you go. You don't need to sort of really do a lot of work to make it work in different parts of your application or different applications. But there's 2 problems with this. The first one is styling. Styling in a component-based architecture itself has 2 problems, right? The first one is naming. You get naming clashes. Everybody's had this before. It's a very typical problem, right? We have a header component, we have a footer component. we give two similar classes .title, and suddenly we have a conflict, and our title has a background color of yellow and a border color of blue, even though we only wanted one of them. Now, this problem has existed for ages, right? And there were some nice ideas how we could fix this. One of them, for example, was BEM, some sort of naming structure where you have blocks and elements and modifiers, and you try to adhere to it. But really, if you're working with hundreds or potentially thousands of developers, can you really make sure that every single one of them checks for naming collisions? You potentially have thousands of CSS files. How are you going to make sure that that one developer over there, maybe in another country, made sure that that name is unique? You can't. So some very smart people went ahead and created something called CSS modules. The difference here is that instead of having global CSS files, what you do is you associate styles with a certain component. And you import them in your React code. So you go import styles from styles.css, and then you assign a class name of styles.footer. Now in your CSS file, you just write the class name of footer and of title. And what CSS modules does is, it goes ahead and prefixes your app name, and postfixes a hash of the contents of the class to the class name. So what you end up seeing in the DOM are those class names on the left, right? You see my app, underscore, footer, underscore, some sort of hash. And the thing is, suddenly there's no naming collisions anymore. Because even if you have a naming collision, the hash has to be the same, which means the contents have to be the same. So whenever you give something some styling, you know for sure that it'll have exactly that styling. In CSS, we have a second feature, though, that's sort of annoying in a component-based architecture, and that's inheritance, right? Certain properties in CSS, as we know, inherit from parent nodes to child nodes, something like line height. So when we have a line height specified in our header, it'll propagate all the way down, and it'll set the line height further down in its children. The problem is, again, we can have conflicts here. If we set a line height in our header to 1.5 em, but in our footer to 1 em, right? We're going to get a different line height for a title wherever we go, even though we want that title component to look exactly the same everywhere. There's a concept in CSS that's resets, right? I'm sure everybody's heard of reset CSS or normalize.css or sanitize.css. There's tons of them out of there. They aim to normalize styling across browsers or make sure you've got the same styling everywhere from the start. You know, what if we could take that concept and wrap a reset around every single of our components? That's exactly what we're going to do. The PostCSS preprocessor has a plugin called PostCSS Auto Reset that does exactly that. There is support for a new CSS feature called all initial, which resets all of the values and prevents inheritance. The problem is it's not supported anywhere yet. It's a new specification, and as always, we'll have to wait until it comes into browsers. What PostCSS Auto Reset does is it sets all the inheritable properties of your component to default. That means when I use a button component somewhere, or I use a title component somewhere, I know for sure it's going to look exactly the same as everywhere else. There's no more inheritance and there's no more naming clashes. So no matter where I put that component, I know exactly what it's going to look like. And since we now have a styles file associated with our component, why not put that in the folder as well? So now we no longer have to maintain the same folder structure in two different folders, right? We don't have to have a components folder in our CSS folder. We just put our CSS file next to our components. We now have true component isolation. We can push that up to npm again, and this time we actually even get the styles with it, right? We have all that we want. We can just npm install it, and it just works perfectly fine. When I first tried this, I went and built a small app that called an API and fetched some data. And now all of your actions and components and containers are sort of in the same folder. Where do you do data fetching, right? The most common approach in the React world at the moment is, in the Redux world at the moment, I should say, is thunks, where you return functions from your action that can do some sort of asynchronous thing. The problem with thunks is that they really are hard to test. You have to mock the dispatch function, you have to mock some sort of fetch function. You end up with these really long Sinon tests that are horrible to read and they take really long to run, and you're like, oh man, this is horrible. This is not the way it should be. There's a solution to this problem, and I'm going to get to that really shortly, but I want to show you a second problem that component reusability brings that solves as well. Imagine you have a clock component and you have a timer component, right? And the clock shows some sort of time, and when you press on the start button on the clock, the timer should start. And when you press the stop button on the timer, the clock should show the time of the timer. Now, what you would normally do is something like this, right? You would dispatch a start timer action when you press the start button on the clock, and you would dispatch a show time action when you press the stop button on the timer. And that works perfectly fine, but suddenly the component that does this is no longer reusable. We can't use it anywhere. We'll have to include both clock and timer, otherwise it doesn't work. We can't just use the clock, we can't just use the timer. And they're very tightly coupled together, which is not what we want when we want to use them in different applications, right, in different ways. So the solution to this is Redux Saga. Redux Saga uses ES7 generators to tie all of your components together, and you can also use it for really nicely testing your asynchronous flows. So instead of dispatching a start timer action from our clock and a stop and a show time action from our timer, right? We just say, hey, start has been clicked, and stop has been clicked. And then we use a Saga that looks like this to tie them back together. This is ES 2017 code, I think. It's generators. They aren't supported anywhere yet, but there's a polyfill, so you can use them. We use them in production perfectly fine. And what this does is, the yield keyword tells the generator to stop execution. As you can see, we have a while true loop, and that might seem a bit scary, but really what this does is it waits until the start button clicked action comes in, right? So this function doesn't just run endlessly and do the same thing over and over again, it stops there, and that's all it does. And then as soon as that start button clicked action comes in, that function goes on and on and on until it reaches the next yield keyword, and then it waits again. So in our case, we can now put the start timer action, because the start button was clicked, so we'll start the timer. And then we wait until the stop button clicked action comes in. And then we dispatch and stop the timer and show timer and clock actions. And that way we now have two really, really decoupled components that don't care about each other at all. And we tie them back together with Redux Saga. The thing about Redux Saga is that because they use ES7 generators and they give you these effects, what they call them, like put and take, you can really easily test your asynchronous flows, and data fetching is suddenly like a separate thread of your application. Even though it's still JavaScript, it's still single-threaded, right? In my mental model, it's sort of like, okay, that happens over there. I don't have to worry about it in my application. I know the data is going to come in. I know my components are tied back together, but I don't have to worry about it. All right, short summary. The first important thing is split your containers and components. Split your components between containers and components, sorry. Group your files by feature, isolate the styling with CSS modules and auto resets, and use Redux Saga to tie your decoupled components back together. Now in big applications, we always have this problem of performance, right? This is both loading performance and application performance itself. You're going to end up with a ton of JavaScript that's all run in the browser, and the user's going to have to wait ages until he gets it, and then it's going to take really long to execute maybe. You have some old Android phones and it doesn't work anymore. How do you work against this? How can you make your application run faster? Let's take a look at loading performance first. I use Webpack as my build tool, but this also works with JSPM, which Guy gave a great talk about yesterday. There's this feature called code splitting, where Webpack intelligently checks where our code could be split in different bundles. So right now, what's mostly done in the React world is we take all of your modules, put them all together into one massive bundle and push it down a user's line. It's like this 10 megabyte file that the user has to wait for half an hour until your application actually runs. Why should we do that? If we have different parts of our application, right? You might have a settings page, you might have an about page, you might have something like the main application, then you might have a home page. Why do we send down everything, our entire page, just because the user visits the about page? That doesn't make any sense. It's also not how the web has worked traditionally, right? Normally, when you have a web server running somewhere, Apache or something, and you put some HTML files in your folder, the user gets exactly the content he wants. Not more and not less. He gets some common styles as well, probably, and he might get a bit of JavaScript that's shared, but that can be cached. And then the next time the user opens a page, he only gets exactly the HTML he wants. That's what Webpack code splitting does for your JavaScript applications. Now, I would show you some code here how this actually works, but the problem is that this is currently being completely overhauled, and the syntax has changed twice already, and I don't want to show you something wrong. So take a look at the Webpack docs if you're looking into code splitting. It's really nice. The second thing is application performance, right? We want to make sure our application runs fast on every user's device. If you have this big componentry, right, in a massive application, and again, something changes down there. Now we go to the store and we go back to the top level component and everything starts re-rendering, right? And you go like, oh, the top level component is re-rendered, the children re-render, and suddenly then, their children re-render, and suddenly the whole application is re-rendered, right? And we get this sort of, everything's changed. But really, what we wanted to change was only that part. We didn't want the rest to change as well. Why should that change? React gives us a really nice lifecycle hook to make that happen. It's called should component update. It allows us to bail out of updates in our components. So we can bail out up there, there, and there. And we can tell React, hey, I don't want to re-render. I don't want to re-render my children either. Just, go on to the next component, re-render the next thing. Now, we want to bail out as early as possible, really, right? Because if we can bail out all the way up there, no other component down there knows even that something has happened, right? So we want to bail out as high up in our component tree as we can to really maximize the performance impact. So kind of what we want to do is this. We want to return next props does not equals this.props. We want to just compare the two and see if they're different. And if they are, we want to re-render. If they aren't, we can't. This is where JavaScript is a bit annoying. Because if you have two objects with the same contents, they aren't necessarily the same, which is a problem. What we could do is we could loop over every single property and value of our properties and compare it against this.props, right? But it's expensive because we have to loop over every single property. That could be a nested object or a nested array, and then we'd have to loop over every single value and property again. And potentially, since we want to bail out as high up as possible, right? We have these two huge state trees we want to compare, and that's going to take us ages, right? Some very smart people have come up with a better solution for that, and it's called immutable.js. Now, immutable.js, the sort of short answer is it gives you immutable data structures. So what you can do is you can go my state from JS and pass it an object. And it'll make this an immutable object. You have some special getters and setters, and it'll create a new object whenever you set something. The thing is, since this is immutable, right, you can't change that object afterwards without creating a new one. What they can do is they can create a hash of the contents, and they can store it in a private field. So now when you compare two immutable objects, you can simply go .equals. And what they can do is they don't have to loop over every single property and value. They can simply compare the two short hashes and see if they're the same. If they aren't, it's a different object and we need to re-render. If they are, it's the exact same content, so why bother re-rendering? With immutable.js, deeply comparing objects is cheap, right? Which allows us to bail out really, really high up in our tree, really compare huge state trees really, really, really quickly. So now, when something has changed in here, we can simply go re-render, 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 and only re-render exactly the part of our application that we want. Short summary again. What is scalability? Scalability means that a system can handle more users, more developers, or more parts of the application. State management, use a unidirectional data flow. Which one specifically you use doesn't really matter. Redux, in my opinion, is the nicest because it's pure and easily testable. Architecture, split your components between containers and components. Isolate your styling. Group your files by feature. And use Redux Saga to tie your decoupled components back together and for data fetching. And then performance. Use Webpack code splitting. And use immutable.js to get deep object updates really, really cheaply. Thanks so much.
Excellent talk, Max.
Thanks.
How about a few questions?
Hi, thanks for the talk. So I have a question, like a follow-up question to the part about CSS and resetting everything. Of course, we know, everybody who works with CSS, that there's implicit inheritance of properties down the classes that causes a lot of problems, but it has also some positive sides, of course. like in the example you showed with the line height, for example, can you really, like, I suppose usually we want to keep the line height, the same for most of a part of our application, and can you really trust developers that everybody will remember to set the proper line height every component he will create? Because I would like to set it like once and for the whole application, not to have to set it in every new like feature, like in your example.
So the real difference between an auto reset and the way we write CSS normally isn't that we now no longer inherit, right? We just don't inherit by default. You can still inherit if you want, right? You can set line height to inherit, and it's going to inherit your component, your parent's line height, and that's fine. We just don't do it by default, which allows us to keep our components really, really properly styled in exactly the way we want. It doesn't make sense for some components. I agree. It doesn't make sense for all of them. So I disable it for some components where it doesn't make sense. But it makes sense for a lot of them. Like button is a very typical example. I've had tons of problems with a button that looked entirely different across all parts of my application just because it inherited the properties.
Hi, great talk. Thanks. I also use Redux Saga. It works tremendously well. But what concerns me are the tests. So tests are really easy to write, but actually they are not testing much. They're only because the Redux Saga test is one big mock of everything. So every function is never called. So for example, when I have an order process and someone is going to the order form from, let's say, Facebook coupon code, link with the coupon code, I'm saving this coupon code to the local storage, so in case of some rewrite or the coupon code is still there. And the problem is that after the purchase, I'm removing this coupon code. And I'm not able to check when with Redux Saga test whether something was really written to the local storage and whether it was cleaned, because there will be never any side effect. But when Redux Saga is about side effects, I would like to test them. So how can we solve that?
So I think, from my perspective, when you test Redux Saga, it's a unit test. A unit test should really only be concerned with what happens in that function, right? We don't want to test every single side effect. That would then be an integration test. It's a totally different type of test, right? Like if I want to test that it writes to local storage, it fetches the right data, the API works, right? I'm not going to do that in a unit test. That's way out of the scope. What I want to test is that my function, my Saga, does exactly what I tell it to and nothing else. And then if that really goes and does what it should, that's a different part of my test, right? Does that make sense?
It also be a problem. Let's say I'm passing to one of the, because there is the call effect, right? First parameter is a function, then there are parameters to that function, which was the first parameter. And when I pass the function as a parameter, it can be undefined, for example, because I made the wrong import, I just mistyped it. And Redux Saga will be fine with that, because it doesn't know that this is the function, but I passed undefined, and I check whether I passed undefined in the test. So this still will be the problem I face the runtime somewhere in my code later.
If you don't want runtime errors, use Elm, basically. JavaScript has runtime errors. That's the way it works, right? Undefined is a function. Everybody's seen this before. It's nothing Redux Saga is meant to solve, right? There's different solutions for that, really. Yeah, but then, you need to adapt to how Redux Saga works, I guess.
Hey, I have a question about immutable JS and
yes.
where to apply it. Because the gentleman on my right is writing closures, so he has immutable data structures all over the place. JavaScript, you don't. Yeah, I see a lot of thumbs going up. We used it, actually, with the gentleman on my left, with some project just for the state. But then you notice that whenever you move from getting stuff from web services or other parts of the application that kind of expect JSON structures, and over here you have immutable, and you access them in different ways because you cannot use array indexes anymore. You have to use .get, and the API is completely different. It's really hard to figure out. So, am I going to use immutable everywhere or only here and here and here, right? And how does it affect like all the libraries that I can use?
Immutable actually has a new type of data structure called a record, which allows you to access your data exactly how you would a normal JSON object. So you no longer have to do .get. You just do whatever your property is, and that's it.
Okay, okay, this is a longer discussion.
Okay,
Oh,
come talk to me afterwards.
All right, one more quick question.
Hi, you told about isolated styles from components, and what do you think about using Shadow DOM? Because browser already use it in, for example, HTML5 player.
Yeah, I guess if you can do it. But the thing is, I don't expect my entire team of developers, however many that might be, to know how to use it. That's a bit of an early assumption, because we could just use Elm and it would fix all of our problems, but we don't because nobody knows it. Right? It's the same problem here. We could use Shadow DOM everywhere, but then nobody knows how to do it. Right?